Hello, welcome to my new video about pH measurements and calculations for acids and bases. Basically, a pH scale indicates the acidity or basicity of a solution. It ranges from 0, meaning very acidic, to 14, meaning very basic. The pH scale is rather similar to the temperature scale, assigning relative values of hot and cold temperatures. The formula for pH of a solution is pH equals negative log of the hydrogen ion concentration of a solution. pH concepts are developed from observations such as when you add an acid, the hydrogen ion concentration increases while the hydroxide ion concentration decreases. If you add a base, the reverse happens, that is, the hydroxide ion concentration increases while the hydronium ion concentration decreases. When both concentrations of the ions are equal, the solution is neutral, and in any solution, the product of the two ions, that is the hydroxide ion concentration and the OH ion concentration, equals this number here, which is 1 times 10 power negative 14. So how do we measure pH of a solution? pH can be calculated if the concentration of either the hydronium or hydroxide ion is known, or it can be approximated using an indicator or a pH paper that develops a color related to the solution pH. This is not accurate, but it gives an approximate number or value of pH. Then it can also be measured using pH meter, whose sensor measures an electrical property of the solution that is proportional to pH. So calculating pH. We can calculate pH of a solution if we know the hydroxide or hydronium ion concentration of the solution, or we can calculate the hydronium ion concentration or hydroxide ion concentration if we know the pH of the solution. And we apply these equations here. That is, if you know the OH of the solution, you can always calculate the hydronium, because the product of these two equals this number here. And from the hydronium ion concentration, you obtain the pH of the solution. Let's take an example. How do we calculate the pH of 1.0 times 10 power negative 4 molar hydrochloric acid solution? We know hydrochloric acid is a strong acid, so it dissociates completely in water to produce the same number of moles of hydrogen of hydronium ions. Therefore, the hydronium ion concentration equals this number. So substitute and solve, then you get 4.00 as the pH. Now note, here we have 2 sig figs and here we have 4. Why? Because in pH calculations, the number that comes before the decimal point doesn't count as a sig fig. So here, these are the sig figs we take. Now, what about if you have the pH of a solution and you want to calculate the hydronium ion concentration? What you do is use this formula. Hydronium ion concentration equals 10 power negative pH. pH is 6, 10 power negative 6, so you get this number. Here 2.6 because pH here also has 3, but the 6 doesn't count here. Then how do we calculate the pH of a base? If you are given a base like potassium hydroxide, which is strong, the OH concentration will equal to the molarity given, because the mole ratio is 1 to 1. And so using the OH concentration, you can calculate the the hydronium ion concentration. From this relationship, we know OH, we know the products of the two equals this. Then substitute the hydronium ion concentration obtained is this value, from which you can find the pH. You could also find the pOH and then subtract from 14. Then what if you are given the pH and you are told to calculate the hydroxide ion concentration? Find the hydronium ion concentration using this formula, which is obtained as this number here, and then substitute. We know this is unknown, and then solve. This is the value obtained. Now this is an example of the common stuff we use in our daily lives and their respective pH values. You can see hydrochloric acid is the most acidic here with pH 0, and sodium hydroxide the most basic with pH equals 14. You can see black coffee pH 5. Basically here, the lower the pH, the more acidic, and the higher the pH, the more basic, as can be observed from here. And each 10-fold change in concentration changes the pH by 1 unit. Thank you for watching. Stay tuned for more videos. Subscribe to my channel and like or share if you found this useful. Thank you.